Can humans actually live on Mars? Every new discovery changes the answer. If the answer is yes, some of the first people who go may never come back. Not because something goes wrong, because their bodies might not let them. NASA has found something on Mars that might change how we've been thinking about survival there. But first, we have to understand what deep space does to the human body. We've studied astronauts on the ISS, but that is still inside Earth's protection. That's not deep space. That's a space suburb. Artemis 2 was different. 4 astronauts beyond Earth's magnetic field. One of the first real crude tests of this environment. The Moon to Mars plan exists, but what does the body actually go through in these conditions? Imagine what it actually feels like. It's day 3 of Artemis 2. You're floating in a capsule the size of a large SUV. Outside the window, nothing. Your coffee stays sealed, because if you open it, it goes everywhere you don't want it. And meanwhile, invisible to you, radiation is already interacting with your cells. Now picture this not for 10 days, but for 7 months or maybe years on the surface of another planet. What would another planet feel like? What would happen if we stay? Because if humans are ever going to stay on the Moon or travel to Mars, every one of these biological systems has to work. And right now, not all of them do. Let's go through them, one by one. The first thing that matters whether humans can live on Mars is what is going on with the body's fluid when there's no gravity to manage it. On Earth, gravity keeps your 2 liters of fluid pooled in your legs. Now remove the gravity, and the body starts to shift. Fluids drift upward, pooling in the face, giving astronauts that slightly swollen look. They call it, half-jokingly, puffy face and chicken legs. The body is giving the signal. It is already beginning to rewrite itself. Fluids shift into the head, including behind your eyes. Over time, pressure builds, enough to change the shape of the eye itself. NASA calls this SANS. Short term, that's manageable. On a long-time mission to Mars, it isn't. The change continues slowly until your vision is fundamentally altered. SANS research matters far beyond space because similar mechanisms affect millions of people on Earth. What we're learning up there is starting to reshape how we understand pressure-related disorders in the brain and vision impairments on Earth. And that was just the eyes, because what comes next, you don't see. It happens inside your cells. Here's the biggest reason we might never live on Mars, and it's not the cold, not the distance, not the lack of oxygen. It's the radiation. Earth has a magnetic field that deflects high-energy particles from deep space. Mars and the Moon don't. Any human settlement on either world would face the full force of galactic cosmic radiation, with far less natural protection than on Earth. On the way to the Moon, the Artemis 2 crew crossed into this environment. The further out you go, the thinner Earth's shield gets. Orion's shielding substantially reduced the dose, but shielding reduces, it doesn't eliminate. What gets through is high-energy particles speeded up by ancient supernovae to near the speed of light. And every now and then, while you reach for your water, one of those particles hit your DNA. You don't feel it, but your DNA does. Your repair systems start to work immediately, but they can't always fix it. For a Mars colony lasting maybe years, the question of what this gene expression change looks like after a decade is one of the central unsolved problems of becoming a multiplanetary species. The same repair pathways that struggle in space are the ones researchers are now learning to target with precision therapies. Studying how DNA breaks under cosmic radiation has deepened our understanding of cancer-related processes on Earth. Recently, NASA found something beneath the surface of Mars. Organic molecules, deep inside, preserved for billions of years. They survived for one reason. They were buried, protected from the radiation above, shielded, hidden. So, if humans ever live on Mars, we won't live on the planet. We would maybe live inside the planet, which completely changes your idea of a view. And even then, survival isn't guaranteed, because radiation is only one part of the problem. The effects on the skeleton are something you can weigh, scan, and feel the moment you land. Mars has gravity, but not enough to guarantee humans can actually live there long term. Your skeleton evolved for Earth's gravity, not less. On Earth, mechanical stress from walking signals bone-building cells to keep producing new tissue. Remove that stress, and the signal fades. Without gravity, bone building stops, but breakdown continues. Your skeleton is not negotiating. On Mars, with 38% gravity, the bone loss would be slower than in full microgravity, but it would still happen. A human who spent years on Mars would return to Earth with bones that may not be able to handle the full gravitational load anymore. The body adapts to a new world. Is it able to reverse that change back to Earth? The very dream that has driven us for generations to explore the universe might be a one-way path. But what did we learn on Earth from that? Research on bone loss in space is already reshaping osteoporosis treatment on Earth. New ways to stimulate the skeleton when the body stops maintaining bone on its own. The same bones that begin to weaken in space are helping people stay upright in their 80s. But more parts of the body change without Earth gravity. While all the familiar objects of daily life are drifting gently around the cabin, the heart slowly forgets how to work against gravity. Your cardiovascular system was built for gravity. Blood is always trying to fall. Remove it, and it adapts, not necessarily in your favor. In the first hours, the fluid shift rounds the heart's geometry. The heart reduces in volume. The human body doesn't just survive the journey, it adapts to maybe even living there, building there, raising children there. A heart that learns to live on Mars may forget how to live on Earth. That understanding changed how we understand recovery after heart failure and after cardiac surgery here on Earth. Let's go on to the immune system now. We still don't fully understand why, but in space, the immune system weakens. Dormant viruses can reactivate. Viruses the body has carried for years suddenly decide to come back. Imagine that in a sealed habitat on Mars. One reactivation event can spread through a crew that can't leave. Artemis 2 didn't go to Mars, but it went far enough to enter the same kind of environment that begins to drive these changes. Not long enough to answer the question, but long enough to start asking it. 4 people, a sealed capsule, no immediate help, just systems, protocols, and each other. Back on Earth, the first observations were expected: balance issues, difficulty readjusting to gravity. That's not the full Mars scenario, but it's the closest we've come to experiencing its limits. What looks like a failure in space is becoming a model for understanding how these systems break and how they might be guided back. These mechanisms are now being studied for autoimmune diseases and cancer treatment. But focusing only on the risk misses the full picture. The human body in deep space is not just failing. In some ways, it is doing something extraordinary. Take the brain. Gravity has shaped every movement you've ever made. In space, that signal disappears. And the brain doesn't crash, it rewrites itself. Which sounds impressive. It learns to interpret a new sensory reality. No up, no down movement in 3 dimensions. A new spatial reality. If humans are going to navigate the surface of Mars, move through environments with no earthly reference points, This capacity is a prerequisite, and the brain, apparently, has it. Ask any astronaut, and they'll tell you about lasting psychological changes. It is documented across every astronaut population ever studied. A shift in perspective. Seeing Earth from the outside, that thin blue line of atmosphere, changes how people think. For the question of whether humans can truly live on Mars, not just survive, but build a life, the psychological capacity for that kind of perspective shift may be exactly what makes it possible. Across all of this, one thing becomes clear. The human body is not fragile. It adapts. It behaves very differently once you take it off Earth to environments it was never meant to survive in. It finds ways to stabilize, to compensate, to keep going. That's how we populated Earth. And maybe with this, we can also populate other planets. At the same time, this research is teaching us how to heal on our home planet. This isn't just about surviving another world. It's about understanding what the human body becomes when it's pushed beyond the one it evolved for. Now step back and look at the plan. Within the next few years, NASA intends to land humans on the Moon again, staying there. After that, Mars. Around 7 months of transit in deep space, a surface stay of potentially 1 to 2 years, and then months again to return. Would Mars protect us? Can we survive years there? Can children be born on Mars? Would they be able to visit Earth? What terrified scientists wasn't any failure of Artemis II. The mission succeeded. The crew came back. The data is being analyzed. What they find so unsettling is how much of this mission still depends on things we don't fully understand. How many of the biological puzzle pieces remain unsolved? Whether the next steps of this roadmap are survivable, we don't fully know yet, and we're going anyway. Now, imagine you're sitting in the briefing room. Someone hands you a document. The fluid pressure problems, the radiation exposure tables, the bone density curves, the cardiovascular adaptation timeline. And then, further in, the mission roadmap. Moon landing, extended surface stay, Mars transit. You read all of it. The cost of going and the scale of what going means. You sign the waiver, and then you sit in the capsule and wait for the countdown. That's what 4 people did. They didn't sign up to prove that humans can live on Mars. They signed up to generate the data that makes it possible to decide whether we should, and how. That's not heroism as a story we tell. That's as a choice made quietly, before the cameras turn on. We are still learning in real time from missions like Artemis II what that actually requires from the human body. What breaks? What reconfigures? The plan is running ahead of the biology. We're just beginning to understand what we still don't know. There's more to explore. Next time, see you beyond the stars.